So you've probably seen the linear search one by now. Binary search is a more efficient way of looking through data. Now, the only downside is it only works on lists that are in order. So you can see here we've got a data set where the data has been put in order. Now, if you've got data in order, there are lots of different algorithms that will work in different ways to look through that list. That's more logical than just starting at the beginning and working through one at a time. Because if you know the data is in order, there are better ways of searching this data that will run much quicker. Okay, so the first step is it would add 1 to the length of the list and divide it by 2 to find out the position it's going to compare with. So again, let's say I'm looking for the number 7. So the first thing it would do is there are 9 items in my list. So it would add 1, divide by 2, reach number 5, and it would look at item in position number 5, which is 23. Now, this is where it gets a bit clever. So it's only looked at 1 item out of 10. What it's going to do is, because it knows 23 isn't what I'm looking for, so it's not the number 7, but it can also work out that because 23 is bigger than the number 7, and we know my list is in order, if the number 7 does exist, it must exist in one of these 4 positions, because it can't exist here, because that's for numbers that are bigger than 23. So by looking at only 1 item of data, I've eliminated 5 places, which is a lot more efficient. Okay, so then again, I'm left with 4 positions to check. So again, I add 1, 4 becoming 5, divide by 2, which is 2.5, and I'd look at item 3. Okay, because it'd always round up. So I'd look at item 3, and then again, I go, right, 19 isn't the number 7, but if 19 is not the number 7, then the 7 can't exist there either. So it knows if the number 7 does exist, it's going to be in one of these 2 positions. So I discard those. And again, 2, add 1, is 3, divide by 2 is 1.5, so I look at position 2. And I've managed to find my bit of data that I was looking for. Just a coincidence. But so in this example, we managed to search through or discard 8 items of data by only looking at 3. It's significantly more efficient than a linear search, but the data has to be in order for it to work. And finally, have you thought about why it might be called the binary search? If you think a binary search has only got 2 positions, 1 or 0, being binary, and every time a search is made, half of this list is discarded. So that's why it's known as a binary search. At A level, you learn a little bit more about how it's stored, which makes more sense. But yeah, every item of data you look at, you're discarding half of the available data. So if this data set here was 3,000 items long, by me looking at 1 item, I can discard 1,500 items of data, which is very, very efficient. Okay, so just to show you an example again, because this commonly could come up in the exam. So let's say, I'll get my pen tool. Let's say I was looking for the number, 44. So what I would do, again, I'll keep the numbers the same, but I'll add 1, divide by 2, and I'll reach 5. So this would be my first check. Okay, and on my first check, I go, right, I'm looking for the item 44. Number 5 is 23, so it's not in number 5, but I also know it can't be in there, or there, because the number I'm searching for is greater. So I'll change colour. So then my next item I look for, I've got 4 positions left. So I'll add 1, which is 5, divide by 2, 2.5. So I'll look at position 3. I know this says position 8, but bear in mind it's 3. So this might say 8, but it's position 3 of the data I've got left. Okay, so my second item I'd look at is 54. So I'm looking for 44. I should probably write that down. I'm looking for the number 44. So it's not there, not there. Then again, I'm left with 2. Green. I'm left with 2 items. So 2 plus 1 is 3. Divided by 2 is 1.5. So I'd look at position 2 because it always rounds up. And 44 is the number I'm looking for. So in only 3 items, I've looked at 3 items of data and searched through 9. So you can start to see why the binary search is quite good.